The Pain of Being Left Out, a noir investigation into rejection. The city doesn't care if you're lonely. It keeps moving, indifferent as concrete. But inside your skull, that's where the real crime scene lives. I'm here to tell you about rejection. Not the kind you shake off with a drink and a sad song. The kind that hurts like a fist to the gut. The kind your brain can't tell apart from a broken bone. This is the neuroscience of being left out in the cold. And sister, it's darker than you think. You've felt it before, everyone has. That hot shame when you're not invited. The cold dread when they don't text back. The hollow ache when someone walks away and doesn't look back. We call it emotional pain, like it's something different, something lesser than the real thing. We're wrong, dead wrong. Your brain doesn't split hairs between a slap and a snub. It treats them both like threats, life-threatening. The kind that could get you killed back when humans huddled in caves and exile meant death. Evolution doesn't forget, and it doesn't forgive. Picture this, your brain is a city at night. Millions of neurons firing like streetlights flickering on. Chemical signals running through alleyways of grey matter. Information traveling faster than a bullet train through the dark. Two neighborhoods matter most in our story. Two districts where the pain of rejection lights up like a crime scene under floodlights. First, the Dorsal Anterior Cingulate Cortex. Call it the dACC if you want to sound like you know what you're doing. It sits deep in the folds of your brain, tucked away like a speakeasy in the frontal regions. Second, the Anterior Insula. Nestled in the lateral sulcus, hidden in the creases where your brain folds in on itself. These two, they're partners, the kind that finish each other's sentences, the kind that show up together at every scene. Here's where it gets interesting. For years, scientists thought emotional pain was just a figure of speech, a metaphor, like saying a betrayal stabbed you in the back, pretty words for ugly feelings. Then they looked closer, they scanned brains, watched them light up in real time, saw the patterns emerge like fingerprints at a crime scene. What they found changed everything. The same neural circuits that process physical pain, real blood and bruises pain, also process social pain, rejection, exclusion, loss. Welcome to social pain theory. It says this: your brain evolved to treat social exclusion as a physical threat, because for most of human history it was. Get kicked out of the tribe, you don't last long against the wolves in the winter, your genes don't make it to the next generation. Evolution doesn't give you a second chance, so your brain developed an alarm system. A sophisticated, loud, impossible-to-ignore alarm that screams danger when the social fabric starts to tear. That alarm, it hurts, deliberately. Let me introduce you to the dACC properly. This region sits in the frontal part of your cingulate cortex, arching around the corpus callosum like a guard watching the gates. It's old. Evolutionarily speaking, it's been around the block. Mammals have had versions of this structure for millions of years. It's a multitasker, a real Renaissance region. The dACC monitors conflict, detects errors, watches for things that don't match expectations. It's the part of your brain that notices when something's wrong before you consciously know it. But here's the kicker: it also processes the distress of physical pain. Touch a hot stove, the dACC lights up. It's not feeling the burn directly, that's happening in other regions, the primary somatosensory cortex handling the raw sensory data. But the dACC, it's processing the suffering, the "this is bad and needs to stop" part of pain, the effective component, they call it. The part that makes pain hurt instead of just being information. Now here's where it gets noir. That same region activates when you're socially rejected. Same structure, same response, same suffering. The Anterior Insula is the dACC's partner in this crime. This structure is buried deep in the lateral sulcus, the fold that separates your frontal and temporal lobes. You'd have to peel back layers of cortex to find it, like opening a Russian doll made of neurons. The insula is your brain's interpreter of internal states. It tracks your heartbeat, monitors your gut, keeps tabs on temperature, pain, hunger, thirst. It's the reason you know something feels wrong before you can name what it is. Think of it as the detective who reads the room, who notices the tells, the little signals that something's off. The Anterior Insula particularly handles awareness of your emotional and physical state. It takes raw sensation and wraps it in meaning, turns a racing heart into fear, transforms a dropping stomach into dread. When you feel physical pain, the insula helps you become aware of it. Conscious of the hurt. It's part of what makes pain an experience instead of just a reflex. And when you're rejected, when someone excludes you or breaks your heart, the insula lights up like a marquee in the rain. Same activation pattern, same neural signature, same experience of suffering. Your brain isn't being poetic, it's being literal. Every good noir needs a pivotal case, the one that breaks it wide open. Enter Ethan Kross and his team, 2011. They wanted to know if this social pain theory held water. If the brain really treated social rejection like physical pain, or if it was all just correlation without causation, coincidence masquerading as evidence. They recruited people who'd recently gone through bad breakups, the kind that leaves you staring at your ceiling at 3 a.m., the kind where everything reminds you of them. These weren't just sad volunteers. These were people in genuine emotional pain, fresh wounds, still bleeding. Kross and his team did two things to each person while scanning their brains with fMRI. First, they showed them photos of their ex, asked them to think about being rejected, to relive that moment when it all came apart, twisted the knife a little. Second, they applied heat to their forearm, not dangerous, not damaging, but hot enough to hurt, a controlled dose of physical pain. Then they watched what happened inside the brain. The results weren't subtle. When people looked at photos of their ex and relived the rejection, two regions lit up bright, the dACC and the Anterior Insula, the same regions involved in the affective component of physical pain. When the researchers applied heat to their arms, actual physical pain, those same regions activated, both of them, partners showing up to the scene together just like always. The overlap was undeniable, statistical, reproducible. The brain wasn't distinguishing between the burn on the skin and the burn of rejection. To your neural circuits, heartbreak and heat were playing the same song. Different lyrics, same melody. But here's what sealed the case. The intensity of activation correlated with the intensity of pain. People who reported more emotional pain from the rejection showed stronger activation. People who felt more physical pain from the heat showed stronger activation in these same areas. It wasn't a metaphor. It wasn't poetic license. It was neuroscience telling us what we'd known in our guts all along. Rejection really does hurt. Step back with me for a moment. Pan out from the individual neurons to the big picture. Why would evolution wire us this way? Why make social pain feel like physical pain? Because for 99% of human history, they led to the same outcome. Our ancestors didn't survive alone. Couldn't. Humans are weak compared to predators, slow compared to prey. We don't have claws or fangs or armor, we have each other. In the Paleolithic, if your tribe kicked you out, you were done. Finished. No grocery stores to visit, no apartments to rent, no social safety net to catch you when you fell. Just you against the wilderness, and the wilderness always wins. So the humans who survived, your ancestors, my ancestors, were the ones whose brains screamed at them when social bonds started breaking. The ones who felt that separation like a wound, who would do almost anything to maintain their place in the group. The ones who didn't care about being excluded, who shrugged off rejection. They wandered off into the dark and their genes wandered off with them. Evolution is a brutal editor. It only keeps what works. And what worked was wiring social pain into the same neural circuits as physical pain, making isolation hurt so badly that you'd fight to prevent it, compromise, cooperate, conform when you had to. These pain-processing regions became watchdogs, guardians against the oldest threat humans faced, being alone. Let me walk you through what happens when you're rejected, the neural pathway from slight to suffering. Someone excludes you, doesn't invite you, ghosts you, breaks up with you. The social wound opens. Information about this hits your brain through various channels. Visual if you see it happening, auditory if you hear the words, memory if you're replaying it later, which you will because brains love to reopen cold cases. This information gets processed in multiple regions. Your temporal lobes decode the meaning. Your prefrontal cortex tries to make sense of it. Your amygdala tags it with emotional weight. But here's where the dACC enters the picture. It detects the conflict between expectation and reality. You expected to be included, to be wanted, to matter. Reality says otherwise. That mismatch sets off alarms. The dACC activates. It signals distress. Not just this is unpleasant distress. The same kind of distress signal it sends when your body is damaged. Meanwhile, the Anterior Insula is monitoring your internal state. It notices your heartbeat quickening, your stomach dropping, the physical sensations that accompany emotional pain. It integrates these signals and brings them to consciousness. Together, the dACC and insula create the experience of social pain, the hurt that feels physical because neurologically it is. Other regions join the chorus. The periaqueductal gray, involved in pain modulation. The prefrontal cortex, trying to regulate and make sense of it. The amygdala, adding layers of emotional memory. But the core of the experience, the suffering itself, runs through these two regions, partners in pain. Understanding this isn't just academic, it's practical, personal, maybe even life-saving. First, it validates what people feel. When someone says rejection hurts, they're not being dramatic. They're being accurate, neurologically accurate. The pain is real. Second, it explains why social pain can be so overwhelming, why a breakup can feel as debilitating as an injury, why exclusion can lead to depression, anxiety, even physical illness. The brain is treating it as a serious threat because, evolutionarily, it was. Third, it opens doors for treatment. If social pain and physical pain share neural circuits, maybe they respond to similar interventions. Some research suggests over-the-counter painkillers can slightly reduce the sting of social rejection. Not a cure, not a solution, but evidence that the circuits overlap enough to be cross-influenced. Fourth, it helps explain human behavior, why we're so desperate to belong, why we'll tolerate abuse to avoid abandonment, why solitary confinement is torture, why social connection is as fundamental to health as food and sleep. These brain regions aren't just neural real estate, they're the reason humans are social animals, the neural architecture that makes us need each other. But like any alarm system, sometimes it goes off when it shouldn't. Social anxiety, depression, rejection sensitivity, these can all involve overactivity in the social pain network, the dACC responding to threats that aren't there, the insula amplifying normal social interactions into catastrophes. Some people's brains learned, through trauma or genetics or circumstance, that rejection is always imminent, always dangerous, so the alarm never fully turns off. Every interaction becomes a potential crime scene. The system that evolved to protect us can become a prison. Understanding the neuroscience doesn't fix it, but it helps. It makes the invisible visible, gives us a map of the territory we're trying to navigate. The dACC and Anterior Insula don't work alone in this story. The subgenual Anterior Cingulate Cortex helps regulate the pain response. The ventromedial prefrontal cortex modulates it based on context. The posterior cingulate cortex processes self-referential aspects of the pain. The right ventral prefrontal cortex seems to help with regulation and resilience. People with stronger activity here bounce back faster from rejection. The brain is never simple, never just one region doing one thing. It's a network, a web of connections where everything influences everything else. But in that web, these two regions are central nodes, critical junctions where social pain becomes conscious suffering. Here's what noir fiction teaches us. Sometimes the darkness serves a purpose. Sometimes the pain is the point. Social pain hurts because it's supposed to, because pain is information, a signal that something needs to change, that a threat needs addressing. Physical pain tells you to pull your hand off the stove. Social pain tells you to repair the relationship, apologize, reconnect, fight for your place in the tribe. Without that pain, we drift apart, become isolated, evolutionary dead ends. The hurt is a feature, not a bug. That doesn't make it easier to bear, but it makes it meaningful. Your brain isn't torturing you for no reason. It's trying to keep you alive the only way evolution taught it how, by making sure you never forget that humans aren't meant to be alone. So where does that leave us? What do we do with this information? We understand, we validate, we recognize that when rejection hurts, it's not weakness, it's neuroscience, it's evolution, it's being human. We treat social pain with the same seriousness we treat physical pain, not something to just get over, something that needs attention, care, time to heal. We build resilience not by denying the pain but by understanding it, by knowing why the dACC activates, why the insula signals distress, by recognizing the alarm for what it is, an ancient system doing its best in a modern world. We connect, we reach out, we build the social bonds that our brains are literally hardwired to crave, because isolation isn't just unpleasant, it's registered by your brain as a survival threat, and maybe, just maybe, we're a little kinder to ourselves and others. Because now we know, the pain of being left out isn't in our heads, it's in our brains, lighting up the dACC and Anterior Insula like a crime scene in the dark. The city keeps moving, indifferent as ever, but you're still here, still standing, still connected, despite the pain, despite the hurt, despite every rejection that tried to convince you otherwise. Your brain knows what it's doing, even when it hurts, especially when it hurts. That's the case, that's the neuroscience, that's the noir truth about rejection. Now you know where it lives, in the dorsal anterior cingulate cortex, in the anterior insula, in the evolutionary memory that reminds us every single day that we need each other to survive. The pain is real, the science is clear, and somewhere in the dark folds of your brain, two regions are watching, waiting, making sure you never forget that being human means feeling the sting when someone walks away. That's not a bug, that's the whole damn point.